Hello, everybody. It is Thursday, March 19th, 2026. Welcome to another episode of AWS Databases for AI. Thank you for tuning in. It's always awesome to see you folks here every week. If we haven't met before, let me just let you know who you're talking to real quick. My name is Trevor Spires. I'm a solutions architect here at AWS. We run the show every week, so hopefully we have some returning guests in the chat today. I spend most of my days talking to financial services customers about all things AI, cloud, and beyond. And I'm joined today by an awesome guest from the DocumentDB team here at Amazon. Cody, why don't you let folks know who you are?
Man, I'm bringing the energy. And great to meet you, Trev. Thanks for that introduction. No, I'm Cody. I'm a DocumentDB specialist SA. So not just one industry, all industries. Anybody that wants to talk about databases, anybody that wants to talk about NoSQL, DocumentDB, that's what I do. I love it. It's a lot of fun. So happy to be here.
It is a lot of fun. I've been looking forward to this show because I know it's going to be a lot of fun. By the way, folks, one thing we always like to find out is where you all tuning in from. I'm coming in from the great state of Maine, in the woods up here. Where are you at today,
heck
Cody?
Yeah. Man, I'm jealous. That's incredible. Texas. I'm in Dallas, Texas. Yeah.
Hey, I'm jealous of you because it is 25 degrees up here in the great state of Maine, and I'm going to go ahead and guess it's probably a little warmer down there in Dallas today.
25. I didn't know it was allowed to get below like 32. I thought like 32 was the lower limit. 25.
No, thanks. Yes, sir. Yes, sir. We're down there for now, but spring is coming. Folks, you didn't come to learn about the weather in Maine. No. You came to learn about databases. Today, we've got a really special show in store for you. In fact, I was really intrigued by this topic last week when I talked to Inder from your team, where we had a really nice discussion about how DocumentDB could simplify AI data architectures, which is, to me, as an account SA working at Amazon, super attractive to me because I find when you start building AI architectures with customers, one thing that nobody likes is like, oh, I have to have 3 different databases, but they have the same data in different formats. And so I was really, it caught my attention how DocumentDB could kind of simplify things for customers. And so, yeah, really happy to have you on to walk folks through that today. Maybe you can share what you have in store for the folks that are tuning in with us.
Yeah, absolutely. Inder's fantastic. I love working with Inder. He does a lot for our team, pushing AI and really making sure that we have those AI features developed for our customers. But you hit the nail on the head. I mean, it's overwhelming. You know, AI, Gen AI, RAG, MCP servers. Like I can go on and on about TLAs, 3-letter acronyms. Which I don't know if you knew this, but we have an internal wiki page that just covers 3-letter acronyms, and it is one of my most visited web pages internally. But anyway, it's overwhelming how much there is. You know, how many things you have to take into consideration, and like you said, the architectures are complex. We were kind of chatting about this a little bit earlier, but our job is fun because we get to talk to customers all day long, and we get to learn about all these different challenging problems. And customers talk to us, and I'm saying this because before I was promoted to an AWS employee, I was an AWS customer. I love talking to AWS because the AWS SAs talk to everybody else. Well, tell me what everybody else is doing. What are you seeing? And that's what customers are doing with us. They're coming to us and saying, what are you seeing other people doing with Gen AI? Like, well, what I see other people doing is asking what other people are doing with Gen AI. And so, because it's hard, it's overwhelming. You go and Google RAG architecture diagrams and you see, like you said, I have to have 5 data stores. I have to have all this code that's kind of glued together to do this. And it's overwhelming, right? All I wanted was a chatbot. And now I got to build this 13 service workload just to deploy that. It's hard. It's very hard. So Inder, last week when you talked to him, he kind of gave you a simple view of that, and that's what I want to do. I want to expand on that, show you another simple view.
Amazing. Yeah, I think it's really powerful for developers, and yeah, just plus one. It's like when a customer says, "Hey, I need to do a RAG chatbot," what they don't want to hear very next is, "Great, we need to set up an ETL pipeline for you to load stuff in your vector DB so that way you can maybe eventually get that chatbot working."
How are you with Kubernetes?
Yeah.
Yeah.
Right. It's just like, come on, can we? One of my favorite leadership principles here is invent and simplify, and I'm always like, let's lean into the simplify part for customers. And I think DocumentDB seems to have done just that when it comes to AI. So, I mean, at a high level, I think if you're tuning in today, stay with us for the next hour. What you're going to experience is this. We're going to have a lot of conversations about all the different trade-offs and various things you need to consider when building a RAG application. We're going to actually, Cody has prepared an awesome demonstration as well as some configurations that he'll share. We'll share all the code in the chat here in just a second, so you all can play with this yourself after today's session or here live with us. And at the end, we'll show you a kind of nice demo of how this gets all pulled together. But I would love if folks in the audience follow the lead of one of my favorite audience members, Luis Lopez, who always has amazing questions for us along the way. That's a big part of why we do these live, is so that we can make sure everything is super duper clear to the audience that is tuning in. Now, before we get into gosh, I don't know who this is, by the way, Queen of Emojis, but this is a really good username. It just caught my attention. Thank you, Queen of Emojis, for joining us this week. And you know what, Lewis, hold tight. Hang on with us for the next hour. We're going to answer this exact question and more.
Oh, that's a great question, Lewis. Yeah. Well, we're going to answer that specific question.
Yes, absolutely. So hang tight, and we'll do just that. Did I miss anything, Cody? Anything else that we're going to dig into that I should have called out earlier?
No, I think that's it. You know, it's going to be fun. You know, some of the things that I'm going to go through with this too are, like I mentioned earlier, it's overwhelming a lot of times when you want to build something, because like you mentioned, you know, I look up a RAG architecture. Now I have to add all these new services, and that's complex. Now I have to learn that. But you also have all these variables, and what do these variables mean? And what does it mean if I pick this one or that one, or this model versus this model? And for me, honestly, like I'm you know, kind of a confession here. I was selfish when I built this, because I built something that I wanted to see. I didn't find anywhere else. Like, I understand words. I understand what you're telling me about this stuff, but show me. And there was nothing I found that would show me what you mean by pick this variable or that variable or this model or this model. Like give me an example. I'm a hands-on learner. Show me that. And that's what I did. Is the demo we're going to go through, the code we're going to go through, is going to give you that real world example. So it's going to be fun. I'm excited about it.
I'm excited about it too. Let me know when you're ready, and we can start popping stuff up on the screen. It looks like the audience is excited too. And folks, if you're tuning in from YouTube or Twitch, I went ahead and threw a link in the chat that has some nice examples for DocumentDB if you wanted to get hands-on yourself. And then all the code that you'll see today should be in that repo in the coming days or weeks. So should we start with, I see you have two things shared. I see a diagram and I see some code. Which one should we start with here, Cody?
Let's kind of baseline with the audience real quick. I just want to make sure that we all know what RAG is. Retrieval.
Yeah, that's a great call out. Yes.
That's it. Basically, RAG is a process. It's the process. I sound like I'm a dev guide all of a sudden. I need to bring it down a little bit. You have large language models. Large language models are trained on massive amounts of data. The analogy I hear all the time is there's large language models that were trained just on Wikipedia. Like they went through every single page of Wikipedia, and that's all your knowledge together. And the point of training this vast amount of knowledge is to generate output to questions that you have. So like if you interact with it through a chatbot, it can answer your questions. Think like ChatGPT, you know, hey, I find me a restaurant in the Dallas area that's open on Thursdays that serves barbecue ribs, and bam, it's going to go through and it's going to give me complete sentences. It's wonderful, right? RAG extends the power of LLMs by incorporating specific repositories, specific pieces of data. So for example, your internal knowledge base, your organization, your company's internal knowledge bases. And you do this without having to train your internal knowledge with those LLMs. LLMs, large language models, are public. Anybody can access them. Probably don't want the public to have your internal documents. That'd be bad. You know, that's we don't want to keep that internal. So it's really a cost-effective way of utilizing those large language models with my internal data to augment it and essentially prefer it, right? I'm still going to use that knowledge you have, but you're going to rely heavily on my information to bring it back. Trevor, you talk about AI all the time. How is that? Does that make sense?
I think that's a great explanation of it. The kind of like the version that I would like maybe explain to my parents who are not super technically savvy would be like, these AI models, they're really good like reasoning machines, and they're really good thinking machines. They're not very good at storing things.
Right.
They're not good databases, right? And so that's why fundamentally, for the question of kind of like why RAG, it's like you want models to have up-to-date context. You want to and think of a vector DB or like a RAG architecture as like almost like a database sidecar to your LLM, to just make sure you're injecting it with the right context so that it's accurate, it's performant. Now I would have confused my mom and dad at this point, but the first sentence held true. So yeah, yeah, go ahead. I guess the other thing is, for folks that are tuning in, this tends to be like if you're learning AI, it's one of the first things you're going to run into, right?
Oh,
like how to set up RAG.
Yeah, and to Lewis asked a question earlier. Well, what's the advantage of RAG? I'm going to show you that. I'm going to show you exactly what happens when we ask a question to a RAG model versus just general LLM. But yeah, so RAG was the big 3-letter acronym in 2024. In 2024, like at reInvent, that's what all the sessions were about. We talked about RAG, and then last year it became MCP. That was the big Gen AI thing, and it changes, but RAG is still relevant. It's something that customers are still interested in, and it's something that this demo, what we're going to go through, is actually stemmed from customer conversations. The conversation is, listen, I have these vast treasure troves of internal knowledge. I have these wiki pages. I have, custom websites. I have internal knowledge repositories that hold data, and I want to make that available for everybody to use. We do this internally at AWS, right? I'm on a team that has a bunch of DocumentDB people. We have like 5 or 6 solution architects that just deal with DocumentDB. And we encourage everybody, if you find something cool, or if you have a workaround or something unique that we didn't know about, go write a document about it. Write it down. It's asynchronous, right? You don't have to set up a meeting and tell us all about it. Go write a document about it internally so it lives there. And now I can search for it and hopefully I'll find it. But the problem is, if it's asynchronous and I have a teammate that writes a document, I don't know that he wrote it unless I search for it. And the only way I'm going to find it if I search for it is if I search for that exact keyword. Like if I search for this exact thing, right? If my teammate writes a document about a potato and I go searching for oval brown vegetable, I'm not going to find it. Like it's never going to pop up. So now what am I doing? I'm spending time searching for other documents. Has somebody else solve this? And then I'm, jumping to all these different repositories and I'm wasting time. And then once I can't find it, I'm going to go build whatever solution myself and possibly duplicate the work. And it would be so much nicer to have all that data from all these repositories in one place so that I can very easily find it and shorten that time to build a solution. And that's where this came from, is our customers said, help us, we want to do this. And that's usually done through a RAG architecture, and that's usually done through a chatbot. What you pulled up here, by the way, this is like, if I went and Googled RAG architecture, this is probably what I'd wind up with is, okay, I have this front end, the very pretty user there that's talking to the application to type in their question. And behind the scenes, I have all these different data repositories. I had this conversation history, right? That's what you said is the thing about RAG is we want that history. We want to remember what we've been talking about. So we have to have a data repository for that. Then we have those 3 databases there in the center. That's usually our internal data stores where we have all of our different data repositories. And then at the bottom, we have a vector data store where we have to hold embeddings and search the data. And so we have this long process where if we want to ask a question, we have to go hit all these different data repositories and figure it out. DocumentDB supports vector indexes. And by supporting vector indexes, all these different layers of databases that you see there can be one. It can all be DocumentDB. And I have a cool picture that shows that, but I forgot to bring it up. But imagine you squished all those databases into one icon, and that icon was DocumentDB. That's what the RAG architecture would look like. You don't have to have this complex database structure. You don't have to have all these, this code gluing it all together. It's just one place. And that's what we're going to walk through in the code I'm going to show you. So
amazing. Yeah. No, I'm looking forward to it because I think to your point, it's like, I think when you talk to Cody and I, we're going to compel you all, like, if any of this isn't clicking, I think the best thing you can do is go try to deploy it yourself. And so
100%.
a lot of what you'll see today, actually, you don't have to have a tremendous amount of data to kind of understand and build something like this. So a lot of this can be done within the free tier of what's available within AWS and DocumentDB to experiment with something like this. And so if you are one of those developers or builders that has started to experience the challenge that we're talking about of, kind of like an ever-growing number of endpoints and processes to get data where you need it for AI, consider taking DocumentDB for a spin and trying out what we're going to show you today. And so with that, I'll hand it over to you, Cody, to get us kicked off there.
Let's jump right into the code here. So what we're doing everything here in SageMaker. This is a SageMaker notebook. It's an interactive Python notebook. So everything can be done in Python. Kind of biased that way. I'm not smart enough to code in Java or C#, so I do it in Python.
I maintain about a high school reading level, and so Python's good for me.
Yeah, there you go. We're on the same page here. So what we're going to do, we're going to start off. We're just going to do some basic tasks. We're going to install some libraries that we need. We're going to import those libraries, and you can see that we're using a lot of LangChain. Don't worry, this is not going to be death by code. Like, I'm not going to dive deep into each one of these functions and modules. It's going to be a high level. But here we're, and as I say that, I'm going to jump directly into something specific. Gradio, we're going to set up a chatbot interface at the very end where we can type in and use Gradio to host a web page, ask questions, interact with our chatbot. So we're going to set up some connection parameters to DocumentDB. And I'm going to pause here because I think that this is an important thing this is an important piece to consider, is this rate limiter and circuit breaker. So we're going to use Bedrock for our LLMs and for our chatbots. And Bedrock enforces service quotas, requests per minute and tokens per minute. And this isn't unique to AWS. This is most services that offer some kind of GenAI API or kind of LLM API. And what this means is that for our rate limiter, what this means is, let's say that you have 5 users that ask a question all at the same time. Well, those 5 questions are going to go through, and let's say that your cap is those 5 requests per minute or whatever it is. If user number 6 comes through and arrives and asks a question, what's going to happen is they're going to get an error. It's going to say, nope, you're throttled, chill, just wait, try back in 30 seconds. So what that means is you have to handle that. You have to handle that in code. You have to have an error handler, an exception handler. Well, what this rate limiter does, is that 6th request comes in, it's going to get stuck in this wrapper, and it's just basically going to wait. It's going to wait until one of those first 5 drop off, and then it'll push through. So what does that mean? That means that my 6th user isn't going to get an error. They're just going to wait a little bit until one of the other questions is answered, and then it's going to go through. So this is one of those these 2 pieces here, the rate limiter and circuit breaker. This is helpful for other services, not just AI services. So the circuit breaker, what this is saying is, let's say that my network is absolutely saturated and I'm having connection issues getting to Bedrock. If 50 people come in all at once and I can't reach it for like 90 seconds, well, I'm gonna hit the circuit timeout at 30 seconds. And then what happens after the 30 seconds? All 50 are gonna come back and hit it again. Like, I'm just gonna keep flooding it with wage, right?
Yo, this is one of my favorite things about working with Amazonians, especially, and our solutions architects, is like what you're describing here actually doesn't have much to do with DocumentDB, but you've seen, based on your real world experience, that like imagine this, okay? You've spent weeks tweaking a RAG database, and you've been testing it, and it's working, and you're like, amazing, my app is working. I'm going to release my chatbot to the company or to my customers. You release it, and then an hour after you release it, you get a bunch of tickets or you get a bunch of errors in your observability saying, oh, customers are getting 429 errors or capacity threshold net errors, right? And I love that, even though this is kind of focused on DocumentDB and integrating that, you're also making sure that the solution has consideration for what is a common bottleneck, right? Which is an upstream inference provider potentially getting saturated. So, so it's a really good call. I'm glad you have that built in here. The good news is, if you ever do get a 429 from Bedrock, especially if you're a customer that has an SA or a TAM reach out, and we can help make sure that we solve that problem for you.
100%. And really, the focus here is that user experience, right?
Yes.
Because both of these is, for the rate limiter, if I don't have this, my user will get an error. The circuit breaker, my users will wait 30 seconds and then get an error. And the whole thing here is, I understand that there's limits, and I understand that I could have a very busy application with tons of people all hitting this all at once. I want their experience to be good. I don't want them to get errors, because as soon as I get an error, I'm not invested anymore. I'm like, man, this is broke. Come back to me when it's working. So yeah, it's we'll call it quality of life things. Did I run this? I don't think I ran this. Let me run this cell. I'm supposed to be running this live. The next thing that we're going to do is we are going to scroll down. We're going to set up our connection to DocumentDB. And this is, like kind of like the title of the show says, is this going to be our data store? This is going to be our RAG data store. We're going to put all of our data into this namespace called rag.chatbot. I want to spend a couple minutes talking about this, because I think this is the important thing. And this kind of goes back to Lewis's question earlier about how does DocumentDB support Gen AI workloads and vector workloads. So DocumentDB allows for vector indexes, and vector indexes lets you store vector embeddings inside a document to do vector searches against those indexes. Man, if I had $1 for every single time I said vector, it is going to be an expensive show. I'm gonna try to back off that word now. So DocumentDB supports 2 different types of vector indexes, and this is what allows you to do these chatbot interactions. This allows you to do these lookups to give you that relevant information. So we have one that's called IVF flat and one that's called HNSW. And the difference here, so IVF flat, what happens is we take all of your data and we put it into clusters. So let's say that I have a database of athletes, like I have a bunch of athletes in the sports they play. Well, IVF flat will create different clusters of my data based in sports. So I'll have like a soccer cluster where all my soccer athletes go, and my football cluster, my baseball cluster where all my baseball clusters will go. And so what happens is when I send a query and I say, show me a left-handed pitcher that has a 95-mile-an-hour fastball. Well, it very quickly is going to put me into the baseball cluster. And then once I'm in there, I can search all those documents around me to find all those other indicative data pieces, right? So it puts me in the right neighborhood to get me started. Now, the problem, though, is with these IVF flat indexes is you have to have all of your data there in order to create your index. You cannot pre-create an index and then add data, because what happens is any new data that comes in later has to fit into the neighborhoods or the clusters I already have. So I have my baseball players, my soccer players, my football players. Well, let's say I add tennis players later. Well, my tennis players might get put into that baseball neighborhood, because tennis didn't exist when I created this. So what does that mean? That means, well, I'd have to drop my index and recreate it later. And, that can be an expensive process. You want to avoid that if you can. So if you have a data set that is busy, like a lot of writes, a lot of inserts, a lot of updates, you're going to have to re-index a lot, or you're going to do what we're doing here is we're going to use that other index, that HNSW. HNSW is slightly different. It's like a multi-level network that creates webs between all the data points. So now let's say I want to find a female basketball player that played in the WNBA and is from Dallas, Texas. What HNSW is going to do is going to start off somewhere. It's going to start at a point. And it's going to say, I found a basketball player. Let me find all the connections this basketball player has to other basketball players. It's going to follow this web. And then it's going to find female basketball players and follow those connections. Like, okay, well, which one of these female basketball players play in the WNBA? Follow those connections. And then all the way down until it finds them from Dallas, right? So it's like a web form. It's almost like a graph database. I'm not going to get technical. We're not going to talk about graph databases because I don't understand graph databases. But it's a web kind of architecture here. Now, the reason we're using it is because you don't have to pre-train it. You can create the index before you even have data, which is exactly what we're doing here. Is we're pre-creating our index before we even have data inserted. And so
if I could summarize, it's kind of like the HNSW has like flexibility to where you can create the index and then load data after, right?
100%.
I'm sure there are some other nuances as well. And the other one is
Sure.
that you really need to have thought out your data model in advance when you're doing the previous version. One quick question I want to field from the audience is which I think is an important question, especially for people that are designing these systems. They asked, like, they clarified, actually, they're kind of curious what the latency impact of this is. And I'll take this, and maybe you can validate my account SA, not rag wizard version of what this is. But in my experience, what I've seen is, when done well, RAG actually can massively improve latency of an AI application. So, like, and here's what I mean. If you look at the diagram we have on the screen here, you can see the various steps involved in doing a vector database lookup and responding to a customer. Of these boxes, the most latency intensive part of a chatbot workflow is almost always the LLM call itself, the inference itself, right? And so where I've seen vector databases really improve end-to-end latency is when they can make it such that you're injecting like less context into the LLM and getting more specific about what you're putting into the LLM. And that comes, I think we'll talk a little bit about this. That comes down to like kind of chunking and tuning the vector database so that way you're getting the right amount of context put into the model. But what I've experienced is VectorDB has the potential to both improve latency and then also dramatically improve accuracy for things that you want the model to be able to perform really good at. So anyway, curious what you've seen out there in the field, Cody.
Yeah, 100%. And here's a cool thing, Trevor, is we're going to get further into this. I'm going to show you exactly what that latency impact is. And I'm going to show you exactly what the responses are. Because like I said, this didn't exist. I couldn't find this, and I was curious myself, so I had to build something to kind of learn it. But yeah, 100%. If done well, it will dramatically decrease it. Because think about that. Like if the more context you're feeding that chat agent, all it has to do is turn that into English. Like all it has to do is reorganize that and give you something back that you can understand. It's not having to do a whole lot of research, and it's saying, listen, I'm looking for basketball players in WNBA from Dallas. You have an index set up such that I get my data back. I got my 5 documents back. I got my 5 people back. Cool. I just got to present this in a way that you understand. I don't have to do all this logic, because if you didn't have that, you're relying on it to make its own connections and figure things out. And that's going to add latency to that experience. So 100%. Yeah.
Love it. I love it. I'm glad we'll get to dig into that.
All right, so we're gonna skip through this. This is just the boring I'm connecting to DocumentDB part, because we are awesome people and we do things the right way. We're not hard coding our database logins. We're actually going to use Secrets Manager to get that. If you have one takeaway from the session, don't hard code variables or login variables. That's bad. All right, scroll down here. Connection.
And you'd be really upset with me if you saw my OpenClaw server right now, Cody. It's got way too many of my credentials saved in a config file. But hey, it's for personal use. It's okay.
Thank goodness this isn't going to be recorded and nobody heard that.
Right.
All right. So the fun part here is we're going to use the Amazon Titan embedding text v2 for our embedding. This is going to produce 1,024 dimensions. We're not going to get into dimensions too much. Just a vector is made up of a lot of numbers, 1,024 numbers altogether, and it's stored as an array in the database. And the output of Titan embedding is 1,024 of those numbers. The important thing that's relevant to DocumentDB here that I have to point out, and I'm gonna doom scroll up a little bit, is when I create my index, when I create my HNSW index, I have to specify the number of dimensions, the number of embeddings that my document has. This needs to match the output of your model that you're using for that embedding. So for example, if Titan embedding text v2 output 512 embeddings, then I'd have to make sure that my index had 512 there. So feel free to change this as if you download this and use this on your own later. If you change that model ID, check what the output number of the dimensions are, and make sure that matches the index that you're building. DocumentDB supports currently up to 2,000 embeddings within a vector. So, all right, so we're going to get that all set up. I'm going to scroll down because it takes me back to the top of that cell. Chunking. You talked about chunking, and we're gonna talk about chunking a little bit more in depth later. But the thing I'm going to point out here is that this is the fun part. This is where we're going to go collect all the data from our different internal data repositories. So what are we building? I don't think I've actually told you that. Well, what we're building here is a DocumentDB chatbot. I want a chatbot that can talk to me about DocumentDB, building from the vast amount of public knowledge about DocumentDB. I want it specific to DocumentDB. For your case, how does this apply to you? Well, this is where you would get your internal data stores. This is where you would connect your data repositories. But what we're going to do is we're going to pull from, we have a PDF version of our developer guide. I think it's like 1,700 pages, and in line with all AWS developer guides. It's super dry and boring, and you hate living there, but you have to go there sometimes, and it's just easier to talk to an SA and make them go look it up. But that's why we have a chatbot. Chatbots are virtual SA. We have some white papers that talk about data modeling, that talk about migrating to DocumentDB. And we also have a whole bunch of AWS blog posts written by solution architects about DocumentDB. And what we're going to do is we're going to take all that data. We're going to go parse all of those blogs. We're going to go grab all the public documentation. We're going to get that PDF, the developer guide, and we want that to be our internal knowledge repository. That's what's going to live in DocumentDB. Well, we can't fit an entire 1,700 page PDF into a single DocumentDB document, nor would we want to, and you wouldn't put it into a single cell of any database. So don't do that. We have to break it up into pieces, and that's where chunking comes into it. And basically what we're saying is we're going to take all of this massive amount of data that we're gathering, and we're going to break it into chunks of 1,000 characters. Now, context is very important, because if we split the data up, we might lose the context. So for example, if I have a sentence that says, Trevor is a terrible person at Monopoly, but I split it right there, right? If I just stopped at Trevor's a terrible person, pause, and then at Monopoly is in a second document, well, if I'm searching for that later, I'm not going to understand that context.
Yeah, the LLM's gonna start slandering me, because it knows is I'm a terrible person. It doesn't have that super important Monopoly context, which I just got to defend myself. Okay, I am actually the reigning champ at Monopoly at my family's Thanksgiving. We play every single year. I absolutely crush. Now, I will say, I also happen to be trusted as the banker, but that's on them. I'll leave the imagination up to you in terms of.
So this is how I know you're a terrible person at Monopoly. I'm glad I took this analogy. This works
You know
out.
what? You know what? I just validated that.
Maybe both are true. So not planned at all, but perfect analogy. So, but anyway, yeah. So if we didn't have overlap, so what that means is we would want a little bit of a sentence to be included in the first document, so that we have that, so that our LLM understands it, our RAG application understands that, and that's where that chunking comes in. So basically, what we're doing is we're saying, store 1,000 characters and then overlap 200 characters either way from other documents. And we're gonna make some natural separators like paragraphs and line feeds and sentences, but generally that's what we're gonna do. And that's what this section's doing. It's going through all of those PDFs. It's going and parsing out all those HTML pages for our blogs to pull the relevant data. And I'm gonna keep scrolling here. It's grabbing our pricing page, our FAQ page, our features page to get all this data to kind of get it ready to be inserted. So right now, what it's doing is it's taking all that data and inserting it into our DocumentDB collection. Because we're doing a live demo, guess what? I already preloaded my data. I don't have to worry about it breaking. I say that, knock on wood, and I'm sure the demo gods are going to pay me back for that later. But that brings us to the next part. This is the fun part. This is where we create those embeddings, those 1,024 numbers that make up our vector, those embeddings. This is where we have to create those. And this is the part where you get that unique value of DocumentDB, because the source of those documents, all those texts that we have, those 1,000 characters, is going to live in the exact same collection, in the exact same document as our vector. We're going to have both of them all together. So what we're going to do is we're going to take all that data and we're going to feed it to our Titan embedding v2 to get that value back so that we can insert it into our collection. I'm going to scroll down here, and basically our document is going to have three main sections. We're going to have our text content, that's that 1,000 characters with the overlap. We're going to have our vector content, that's the 1,024 numbers altogether. And then we're going to keep some metadata about it. We're going to keep like the source, where it came from. Did it come from a PDF? Did it come from a blog? We're going to keep when was it created? Who was the author? What page did it came from? Relevant pieces of data. And we're going to take all of that, parse it up, and put it into our DocumentDB collection. So I'm going to run that. And if I look here, man, look how quickly that went. That was amazing. Again, data's preloaded. So to show you what that looks like, I'm going to hop over, and I'm connected to my DocumentDB cluster. I'm going to say show DBs. I'm in this RAG database. I'm going to say show tables because typing show collections is too much work for me. And I have this table called chatbot. If I look at chatbot, what I'm doing is I'm just pulling a sampling of documents. And I know that came up fast, but basically this right here is one document. It's one row of data essentially. You can see I have my ID, my unique ID for it. This is auto-generated for you. I have the section of text that got pulled out of my document. So this one came from a source of our developer guide, and it took this 1,000 characters. And we could see that the title is developer guide, is written by AWS. It came from this location. There's 1,779 pages, and this came from page 1554. And here's that vector content. Now, I'm cutting this off. I'm truncating it. I'm only showing you 3 of the numbers out of the 1,024 because if I did, well, here, I'll show you. I did db.chatbot.find1. There you go. There's a lot of numbers there. That's that embedding. That's what Titan is doing. It's creating that for us. So, but
I sometimes am still just like, every time I see vector embeddings, I'm just like, I think I know how AI works, and then I'm like, I have no idea how AI works.
A lot of math.
Somehow
there's
like
a lot of math.
Yeah, exactly. There's like that it's just, you know, every time I'm shocked. I'm like, I could have swore I was talking to you in actual English language, but no, it's all numbers behind the scenes.
I like it when I have to go ask AI about AI. Those are always fun. Like, hold on real quick. I need to go ask, wait, Rufus, I need to go ask ChatGPT about something real quick. Wait, ChatGPT, I need to go ask somebody else about this. Like,
yeah, that's
what
right.
Am I doing? It's just a telephone game, and I'm the human interaction point between them. That's it. All right. So, single store versus multi-store RAG. I think this is a key element. One of the big things that we wanted to talk about. Lewis, you asked about it earlier. We saw it in the diagram. What difference does it make? Why would I want to do that? And that's what this demo does, is because I couldn't find anything that really put this in one place for me. So what we're going to do is we're going to show this architecture. I'm going to show you. I'm going to take 1,000 documents out of the DocumentDB collection we just created. So 1,000 of those documents that were in this guy, I'm going to separate them out into a couple different collections because I don't want to re-embed them. I already have all the data here. We're good. For the multi-store architecture, what's going to happen is I have to go query my table that has an ID and my vector data. So I have 2 tables. I have one table that has a vector content and has an object ID. And because remember, in most cases, I'm using Pinecone or OpenSearch, or if I'm running PG Vector on Postgres, that's my similarity search. That's my vector store. Once I have that ID and that vector, and I found the closest set of numbers, now I have to go to the source repository, whether that's DynamoDB or S3 or whatever, maybe even a different collection, to pull back the text because they are not kept in the same place. This data and this data are in 2 different data repositories, and they're connected by this value. It's just foreign key lookup. So my multi-store architecture here, that's what it's doing. It's saying one table has my embedding, one table has my source document. I need them both. So I have to go do this lookup for the embedding, get the ID, use that as a variable to look up the other one, bring my data back. Thing to remember here too, though, is it's not just for reading data. Think about this as you're loading data. You also have to do a multi-step process when you insert data, right? You have to insert the data into your embeddings, your vector store, capture that ID, return it back, and then insert into your source table the ID and that source document if you're going to keep it in another one. And that needs to be wrapped in a transaction, because if that breaks, like let's say that I insert my embedding value, but something breaks and I don't insert my source document into my source document table, I'll never know. Like if I don't write that on a transaction and step 3 fails, then I'm not going to know even when I'm querying. I'm just going to get bad data back when I'm querying. So lots of extra steps there. And then the opposite side of this is for the single table design. We're basically just doing this. We're taking our data, inserting the vector and the text into one table. So we only have to do one lookup. We don't have to do all these joins. Results may vary, because what we're going to do is we're going to do 5 sample runs with 1,000 documents to see what the impact is in latency and time for doing something like this. I'm going to scroll down, and we can see, well, clearly it takes 846 milliseconds to load those 1,000 documents when I have to do 2 tables, and about half that when I have to go into one table. Oh, wow. It takes less time to load into one table than 2 table. Breaking news there. That's interesting. Here's where my demo gods have failed me. I'm saying that we have to do a join to get the documents. It takes 2.8 milliseconds, but when I only have to look at one table, it's taking 6.2 milliseconds. I'm going to chalk that up to, let's run it again. There you go. 4.4 seconds versus 2.5 seconds. Again, this is a random sampling. Times are going to vary, but what I'm saying is, on average, how long does it take me to query one table, pull back the variable, use that as a parameter to a second query to a second table to get my results back, versus just doing one query to get my data back all at once. And you can see for the multi-store, it's 4.4, single store, 2.5 seconds. So a pretty significant difference in your performance for using a multi-table or multi-store design versus single store. Now, caveats to this, things that you should point out. I'm using DocumentDB as my single data store. I'm not going to 2 different database services. So I'm using one driver, a Mongo client driver. If my data was in S3 or DynamoDB or Postgres, that's a different driver I'd have to load. That's a different data store. That's a different connection pool, a different repository that I have to connect to. So your mileage is going to vary. But again, this gives you a simple illustration of that question earlier. Why would I do what's the advantage of single store versus multi-store? Well, this is one of them. It's that performance. All right, we'll scroll down.
Wait, yeah, no. Before you scroll down, I want to dig into this a little bit. Like,
yeah.
So the before and okay. So this is like, almost a double. Could you just? I'm going to ask an annoying engineer question so I can understand.
Sure.
Could you tell me the insertion time and what that's about? I think the retrieval makes total sense to me. I'm not clear on the insertion bit.
Yeah. So what we're doing is we're taking a document, and we're taking our source document, and we want to embed it. So we're gonna take that source document. We're gonna break it up into 1,000 characters. Now that we have that 1,000 characters, we need to create an embedding for it. We need to create all those numbers. Once we have that, we're going to take that ID and the embedding, all those numbers, and put it in one table. It goes over here. But we also need to store the text, the English part of that, into a separate repository so that we can we have an English value that we can return back to the user later.
So this is literally just like we're cutting that write time, I guess, down because we don't have so many destinations that we have to write to.
Exactly. We don't have to maintain this relationship between the two of them. Exactly. Yep.
Got it. Yeah. Okay. Very cool. Very cool.
Like I said, when we put this notebook out for people to use, play with it. Like, I'd love for people to play with it, change values, and just to understand how this impacts you. I mean, change the sample amount of documents, because as that document repository grows larger, these are going to be more extreme. These differences are going to be a lot more extreme. Briefly, I want to talk about this because this is kind of ancillary to what we've talked about so far. Earlier, I talked about a couple of parameters: EF search, there's EF construction when we're dealing with HNSW. That's way more technical than I want to get. The point here is there's a lot of options. And this is a thing that I see customers get overwhelmed with a lot is, I want to build a rag architecture, but I got to pick these parameters for my index. I got to pick a parameter for what my sample size is. I have to pick a batch size, and I have to pick a timeout setting. I have to pick an LL. Like, there's so many options, and you start walking through it. It's like, well, am I getting bad performance because this parameter is bad, or is that parameter bad, or what should I pick for this parameter? And that's what I wanted to do, is I want to kind of break it apart and show you how each one of these sets of parameters kind of affects workload. So what this one's doing is it's trying to show you, we have different values that you pick when you're creating the index. And you have different values that you can pick when you're searching the index. And let's look at how that impacts your application, your query, your chatbot. So what we're going to do here is we're going to use a couple different values. We're going to say M is, the best way to think about this is M is number of connections I have. When I build my index, when I build my my phone book of relationships, M is the number of connections. So how many teammates each athlete knows. I have a bunch of athletes in my database, and M is going to say, well, how many other athletes does that one know? EF construction, this is the other value I use when I create my index. This is going to be, well, how thoroughly am I going to research an athlete when they get added, right? So if I have a very low M value, that means that each athlete doesn't really know a whole lot of other athletes. And I have a very low EF construction value. That means that when I add a new athlete, I'm not going to do a thorough research on them. I'm just going to, yeah, whatever. We're going to research them just a little bit, maybe just ask one or two people about it, and we're going to be done with it. The other side of that is if I have a big M value, that means that my athletes are connected to a lot of people. And a big EF construction value means I do deep level research on them. So what does this mean? Low M means that I'm going to create an index very, very fast. Low EF search means that when I add new athletes to my table, I'm going to add them very, very quickly. Okay. The trade-off, if those are low, my queries aren't going to be very accurate. Right? I didn't do a lot of research. They don't really know a whole lot of people. So the query results I'm getting, they may or may not be correct. There's just not a whole lot there. The trade-off here is there's a search parameter called EF search. So if I want better results because I have low index values, I'm going to have to make up for that by having a very high search parameter, very high EF search. So what does that mean in English? What is the trade-off there? That means that if I want my data to be able to be inserted quickly into the database and I want to index very quickly, then the onus of performance is now on my client. It's now on the users of my chatbot, because to get them accurate result, I have to use this value that makes their queries take longer. The other side of that is if I set these really high values on the database side when I create the index, now my index is going to take longer to build. I probably need more memory and resources on my database, which maybe that means I spend more money on my database because I need a bigger one. However, my chatbot searches are very, very quick and they're very, very accurate. So it makes that user experience good. That's kind of the trade-off that we're looking at here, right? One versus the other. So what this is doing is this setting three different values. We're using another collection of 500 documents, and we're saying we're going to use low values when creating our index. We're going to use our recommended default values, and then we're going to use a very high values. And then we're going to use multiple different values whenever we search, whenever our chatbot query comes in, from a very low value that doesn't do a lot of research to a very high value. And we're going to look at the trade-off. So we can see immediately that when we have very low values for our index build time is pretty low, 320 milliseconds. But when we set those to 11, we turn that dial way up, our index takes 3 times as long to build. I'm not showing you data insertion. This is just index build time. So, okay, the cost for having better results is my index takes longer. But what's the trade-off here? What's the query? What's the end user's experience? So when we search, we're going to use a very low search value all the way up to a very high search value. This recall at 5, what this is saying is beforehand, we set a baseline. I set a baseline that said, I'm going to ask a question. And the question is, what HNS parameters should I configure DocumentDB search for? That's my chatbot question. And beforehand, I went through it and I found 5 documents that I know absolutely answer this question. So that's my baseline. What this recall is doing is saying, okay, of those 5 documents that I have identified as being the truth, the baseline, how many did it return back? If I have 100%, that means 5 out of the 5 documents came back. We're good. I have a great answer. If I have 40%, that means only 2 of the 5 documents that came back to me have the answer. The other 3 have no relevancy at all. Like they're not helpful. So you can see that when we have a very bad index with very low search parameters, we get no documents back that are helpful. Well, yeah, everything went super fast. I built an index fast. My search went very quickly, but the answer I got back doesn't help me. It's just a bunch of words that it just guessed on. The opposite side of this is if I'm very detailed with how specific I want my index to be in my query, I get 100% recall. All 5 documents that I get back have the information I need. And it just shows you the varying levels as you change these parameters. So again, a little bit more technical than I wanted to get into, but I wanted to point this out for posterity so that if anybody's watching this later or pulls back this notebook, they know what they're doing. They know what this is showing. And it kind of gives them that, well, what do I set these values to be? What does this changing this value mean? How does this affect it? That's how it affects it.
Totally. So, it's so helpful. I hope people are able to find this video that are going through the setup, right? Other than the folks that are here live today, because like I know whenever I'm rolling something out, especially when there's all these flags and all these various settings, it's like, I tend to just take the defaults and then figure out what works. But actually having some context of how to tune things in advance, I think, even though it does require people like me who are not very good at slowing down and learning before I start building,
right.
I think it actually pays off in the long term to have that understanding. Hey, it might be good to pop forward and make sure folks can kind of see what this would look like if they if they were to roll this thing out themselves.
All right. So what we're going to do, a couple more things. We're going to configure. This is our chatbot. Our chatbot's going to use the Claude Haiku 4.5. We're going to set a. We're gonna skip over the chunk overlap. I think we kind of covered that earlier. This is just showing you. Run this later. If you download this, run this demo later because this one's a fun one. This tells you what happens when you don't include in one document that Trevor's a terrible person at Monopoly. Like if you have to split that up, this tells you the answers you're going to get if you split it correctly and you don't. So play with that one later. That one's fun. A prompt engineering. Gosh, this is going to be a career in the next 5 to 10 years, creating good prompts. How do I want my chatbot to respond? This is just instructions for saying, hey, when you talk back to me, be conversational, don't use phrases. I could put something in here that says, make sure you only give wrong answers. So somebody should do that. I want somebody to download this later and put in there, only give wrong answers and send me some of the answers.
I've never tried that. I bet the model will listen. I bet
you it will. So here's this one's a fun one too. And I think this one's going to take just a little bit to run. This is, I'll touch on this before we go into that end user experience, that chatbot, RAG versus no RAG. So what this is doing is we're asking some questions here. We're saying, how should I migrate a relational scheme to DocumentDB? What are the document modeling I should use? How should I look at this? Well, guess what? One of the data pages that we have from our internal repositories is data modeling with DocumentDB, and it has a section that answers this specifically. So we have we know that our RAG architecture can answer this question, and if somebody went into a chatbot to ask this, they'd get this. But we're also going to ask just the LLM with no context of our internal data repository whatsoever. We're going to ask it to answer that question as well. And let's see what the difference is. So number one, here's our without RAG. This is our LLM training data. So here's your migration strategy overview. Phase one, we're already in phase one. Like there's no pre-context, like we're just jumping right into it. We're declaring a constant for some reason. We're jumping straight. We have a table. That's cool. We have a DocumentDB table already. We're talking about reference patterns and hybrid patterns, and these are all words. This is interesting. So this is our LLM. This is the context we're getting back. So think about this. You're trying to make it easier for a developer to make an application, and so you give them a chatbot, you give them ChatGPT, just a general LLM to engage with. They're going to get all this data back, and now they have to read through this, parse through it, figure out how is this relevant to what I'm doing, and it's not. That's the secret. It's not. They're wasting time. With RAG, this is a curated data it's going through. It's pulling from our data modeling white paper, and it's giving us specific examples. And it's saying, tell me more. Are you migrating? What database system are you going through? Is there a particular spot that you want to migrate through with some general overview? So this is that difference. This is that difference maker that RAG's going to give us. It's going to point your developers, your marketing people, all your internal folks in the right direction, give them that relevant information to help speed up the process, get them the data faster. Again, we're gonna skip through this to the fun part. Finally, our chatbot. This is our Gradio interface, CSS. I'm terrible. We're gonna skip that, and we're gonna open up this new screen. that has my DocumentDB chatbot. Hey, ask me questions about DocumentDB.
Wow.
Awesome. So let's say, hey, topical, how does vector search work in DocumentDB? Again, this is using that RAG architecture. It's going to do its work, go against our data repository. It's going to take a little bit longer than I'd like to see it take. It's going to give us an answer, right? There we go. Vector search in DocumentDB works by finding similar data points. Man, I should have put our entire session in this and just had it answer questions for me while you were asking questions.
That'd be kind of sick. We could transcribe this and put it, embed it into a vector database. I just hope that we can redact the part where everybody thinks I'm bad at what is it that I'm bad at? I'm a bad guy at Monopoly or something like that. Yeah,
I'm going to petition to make that the title of this episode when it gets posted later. So, hey, it'll bring views. Here we go. Is serverless available for DocumentDB? So let's ask that question, see what it says.
Oh man, by the way, I sure hope so.
Serverless is available in DocumentDB. You should check it out if you haven't. And it gives you some information of why you want to use it and some good text. Let's ask it a technical question. Let's say that I need to build a partial index on my customer collection, and I only want to index the state field for Texas because, well, I'm not gonna make enemies today. Texas is a great place. Maine's a great place, but let's just say I only want my index to cover Texas. Guess what? It's going to give me, because listen, there are two types of people in this world. There are people that never can write Mongo shell correctly the first time, and they're liars. So I have never once written Mongo shell correctly my first time. There's too many brackets, there's too many parentheses, like I can't do it. And it's so much easier when I can just copy and paste it and have my LLM write it for me.
Yeah, for sure. Especially, like there seems like some definite nuances of the brackets and the things. I thought you were going to say there's two types of people in this world. There's Texans and there's everybody else.
I'm not making enemies today, Trevor. I'm helping people.
We're not making enemies. We're making friends with Texans, which is very important. You want to be friends with Texas.
100%. But the point here is, we went through all that, and I know that we paused along the way and we stopped to talk about some things and deep dives to it. But at the end of the day, what just happened is we walked through an entire example, start to finish. We just hit enter a couple of times, and we wound up with a chat bot that's specific to DocumentDB that gives us that interaction, that RAG architecture. We got to see why RAG's important. We got to see what happens when I change some variables. We got to see what happens when I don't have any kind of source material. And that's the cool thing is you're going to take this once we have this up on our GitHub repo, and you can put your own PDFs into it. You can scrub your own blogs, or you can plug this into your internal thing. The point here is I wanted to give you a jump start to implement this into your environment. I wanted to explain to you why you're going to set some of these variables to ultimately get to this point where I can very quickly index, query, and question my internal data in one place to streamline production and productivity from all my internal users to make sure that they're working on the things that matter and they're not wasting time searching for data and querying data and hoping they find it or redoing somebody else's work.
100%. Super informative session. Thanks so much, Cody, for putting it together and spending the time with us today. If you're still here, by the way, we're watching this later. We'll put links in the description to all of the resources in the repo where this is going to be posted to. We run the show every week. So if you'd like to come back next week and say hi, we'd love to say hi to you again next week. And I think that's a wrap for today. We'll catch you all next Thursday. All right. Bye, everybody.
Enjoyed it. Thanks, everybody.